So after we've learned the point slope form of the equation of a straight line, okay, let's do another example that deals with inclinations. So in this figure, we have a point P, okay, and it's rotated clockwise, okay, clockwise, about the origin O through 90 degrees, okay, to the point P naught or P prime here. So this would be the 90 degrees, and P naught or P prime lies on the straight line L with the inclination of 45 degrees, okay, and write down the coordinates of P prime. So this part, back to basics in form 1. So this would be 5, and this would be the length of 4, right? So after you move 9 degrees, this will become the 5, and this would become the 4. So the coordinates of P prime are 5 and -4. Now part 2, find the equation of L. Okay, remember two things. To find the equation, we need a point right here, which we're good, and we also need a slope of the straight line. Okay, but we don't have the slope, but we have this, what we call the inclination. You still remember from form 3. And we know that the slope equals to tangent of the inclination. Okay, so tangent 45 degrees is 1, so that's the slope. And so the equation of L is y minus this y coordinate over x minus this coordinate. I just move this to the other side times the slope. Okay, so this is what we call the point slope form, if you still remember. And so after simplification, you've got the answer. Okay, now part B. Determine whether this is a point on this. Okay, so what we do is we substitute on left hand side, right hand side. Remember, we don't write the equation. We separate it as LHS, RHS because we're still checking. So we substitute 11 into the x here and 2 into the y here. We want to find LHS first, okay? And that also equals to 0, okay? We put it on the next line. And because RHS equals to LHS, and so the coordinates of Q satisfy the equation of L, and so yes, Q is a point on L. This is a great example that revises all the junior form stuff, okay? Calculating slope, inclination, transformation of points, checking RHS, LHS,